My building is like this. It's like this, pretty simple. It's 5-story building in concrete. It's not much. It's not really complex. And we're going to work just right here in the foundation. So we assume that everybody is finished with the upper structure. So the last part, as I'm telling you, is the foundation. So one of the things that I like to do before start is to go for a project and data, general data, which means the setup of the program. I'm not going to specify any normative or any code. We don't need it right now for this presentation. But I want you to know, I want to tell you that this software works with different normative. You can check all of them. Perhaps if we have time, we introduce something related with caissons. Caissons are not in all the normatives. Normally, we work with Spanish normative. Some countries in America, in Latin America, like Brazil, Colombia, and I think Mexico, they can work with that that model. But in this case, as it's just I'm going to choose anything. It doesn't really matter, the normative right now. Um, Beside that, because we are going to work with foundations, we must choose what kind of concrete we are going to use. In this case, I'm going for the one 250. And in this button on the right is called foundation data. It's because if you want to check the sliding in the foundation, especially for the footings, we must introduce the adherence and the friction angle. This data is coming from the soil, but from the lab. And the next subject is the persistent situations and the seismic and accidental situation. These values that you have here are coming from the geotechnical results from the lab. And in this arrow, what you can see is the table showing you more or less or guide you in the type of soil that you are going to work in this project, in this particular project. The first one, the tension, is called allowing bearing pressure. Is the first information that you are getting from the lab. But the second tension, which is the persistent situation, is more or less 50% more. You see that? Now the tension is going to be 1 kilopound by square centimeters, and the second one, the S2, is going to be 150. It just roughly how to get through this table. In our case, I'm going to choose gravel. Gravel means we're going to work with a good soil. Bad soil could be salt clay, for example. I'm going to choose 3 and 4.5. Okay. Once you set up that, the program automatically get this information here. And the last boxes is called considering wind combinations and also seismic load. These horizontal forces. When you are taking in consideration that, you must select these boxes. Okay, that's it for now. So I'm going to start. So suppose the first thing is we go for foundation. We have separate commands. The first one is foundation elements. The second one is go for strap and tie beams. And the third one is called for is when it is automatical introduction of the elements. I'm going to do it right now. Suppose you have very large building, more than maybe 40 and 60 piles, and you want to know roughly what is going to be the computer decisions. So you make it, you just do it. The program, what it does is something like that. According to the first column, column number 6, they go around and look around in around. They go by degrees, 20 by 20, but it check in around 10 meters what is around. In terms of that, I'm going to make the decision. Accept it. This is the program decision. If it's I can study, I am the engineer, I know what to do, so I prefer, to start with this visualization of the foundation elements, and then I can make my decision. This is the first thing that I do usually. And for the second step, we go for foundation elements. So we're going to create a new one. We can do a single column or multiple column elements. We go for the first one. Could be the reinforced concrete footing, and the other one is more mass concrete footing, and the third one is the pipe cap. We're going to do all of them. We are going to start with the reinforcement concrete footing, and the next step is to select the type. Okay, could be a rectangular one, a square one, rectangular one, an eccentric one. The same for the tapered square footing, also for the rectangular one and the eccentric one. I'm going to work with the eccentric one and accept it. So if I'm gonna start with the first column number 6, look at my cursor. Depending on the quadrant that I move a cursor, you will see that something inside the cursor is moving. So that means that whatever you click, it's going to follow that position. See, if I go in the center, go in the center. So now we're using the center footing. On the right side, I can introduce the middle footing. On the other side, the opposite side, the center, the middle footing, one in the corner, one in the middle, and so on and so on, okay? In the corner. Something that if you click the right hands, we can get straight to this window, and we are going to use the multiply column elements. I'm going to choose, for example, the column number 8 and column number 9. Do it like this. And then with the right click, you see the same commands. And wherever you go, you follow. Set up the right position. In this case, it's going to be like this. And the column goes straight. So remember that the program keep the last command. If you are using this command, you can continue using it. So I'm going to choose these two, and the right position, you see, it's going to be something like this. Okay. So now the next step is to introduce the straps and tie beams. We must define the beam. We have two options. One is the tie beam, which the name say by itself is just to tie. The purpose of that tie is just to make all the elements together. If something happens, if a seismic load is happening, the elements are going to be together. Doesn't matter. Doesn't do any more. Doesn't do more thing than that. And the second case, the strap beams, they also have some kind of moments in the beginning and at the end of the beam. You will see it later. And the third one is the automatical strap beam. That means that the program are going to choose which part of the column, which column are going to are going to how to explain that? It's suppose that the column, through the column, you will get the axes, all the stress moments, and this kind of informations, you get all the effort reaching the pile and will be focused here. That's the purpose of this command. Beside that, we have several kind of type bins. If you click any of them, you will see that the geometry is the same thing. It's 40 by 40. In the other side, with the stripe bin, we can start with the first one, which is 40 by 50, for example, or 40 by 40, 40 by 40, and then you can go up, o sea, the inertia, the geometry are going to change little by little. You can use all of them. And also, you can modify the geometry. I will tell you later how to change it, because there are some countries who use 30 by 40, 30 by something, and we don't have this option right here. But we can set up, we can go back to the main menu. From them, you can start doing your own selection. Be sure that when you are going to do it, will be a variety of choices. If you don't have, a rainbow of information, the program are not going to choose the one you are going to work, that you are supposed to work. So accept, we're going to work with the third one, the automatical one. And you see, if I go from the pillar number 2 to the center, the program automatically are going to select the moment. This is a small moment to show you that all the effort reaching the pile will be focused here. And the other part means that is center footing, and the program in this area is like they are going to select the connecting pipe or tie pipe. So we can start finishing all the connections. Yeah, the program will do it automatically. In this case, this is a center one, and the other one is connected, and the program is going to do it in both sides. We can go straight to the bottom. And from here, from the pillar number 5 to 6, I do it automatically. Okay. So now, the first thing is to start working with the any of these pillars. I'm going to, for example, for foundation, I'm going to edit pillar number 6. And the program itself, well, you have to run the analysis before working with this. If you forgot, the program is going to tell you that there is no calculation going on, so you are not going to check. And they can check, but they are not going to take all the solicitations in the soil, in the foundation. So we have now, we are going to check here that you can change right now the geometry, the materials. You can change the geometry, and also you can change the reinforcement. Options, we can talk about this later. The initial thing is to check the code. This code, if something happened, it will tell you. For now, they say some of the checks have been modified. If I want to see the report, just say yes. And this is the report, and it gives you that we have so many problems. The problems and the things that you have to change are they have different color, like these ones. So the pressure of the soil is we must change it. the bending in the pad footing, we must fix it, and so on and so on. Okay, this report, and for those guys who already know the program, this kind of report is not as well as the we have in the columns and the beams, but we are working on it. So the first thing is I'm going to change the geometry. For example, I have by 17, 30 by 30. No, let's check because I don't have any calculation. I'm going to do the calculations. So we go for the analysis. We can do it now for the design because we're going just on the bottom. Go for the designs. We are going to check the foundation elements and also the strut beams. We had three options: the quick and complete designs and also the iterative designs. The ones I like to use, my recommendation is to use the third one, the iterative design, because they check the geometry of the footing and then the beam, but at the same time, they modify the inertia. And finally, the program check all the changes. So we go for the iterative design. Right now, this is our solution, initial solution. So I'm going to show you in 3D what the program does. It does. This is the solution, the initial solution of the program. We're going to work a little bit on that. And we go first for the foundation. I'm going to edit the center one. Okay, so this is the solution. Is the height is going to be 100 centimeters, but I'm going to change that geometry. I'm going to modify by, say, for example, by 60, for example. Sorry, by 60. Yeah, and then we go for code check. Some of the check has been verified. So now we having problems, you see, but we are changing a little bit. Now we can go for design and we can do it complete. This case complete. Now the programs look for the solutions, and I'm going to show you the report that everything is okay. Okay. One thing that I want to tell you is that when you see, every time you see a criteria of Cype, means that we follow all the way one very famous, well-known engineer here in Spain, which is called Javier Calavera. And this guy is he get a win and an award for his job in this regard. And if you want, they have several books regarding to this subject. And everybody, if you are interested and read Spanish as well, you can have it through, one of the libraries here. Also, I sent this book to some friends in Latin America. If you're interested, because we follow all the way this guy. And well, this well, we already have the designs. So the question here is why this program initially give you the height of 101 meter, and now I changed by 60, and the program allowed me to do so. And also the report is giving me a very nice option, no, the best option. So that means that sometimes, inside the program, we have something that we must check. So I will show you that we will check. If we go back, to the initial window, straight to this button. It's called by positions. It's in the middle. And we have two options here, the floor slab and the foundation. In foundation, we must check the footing right here on the bottom, footing, just something like this. This button, the three yellow color. You see in pad footing options, just straight on the bottom, we have that the selection by default, the program select that the footing depth could be greater or equal to the beam depth without exception. So if my foundation is going to be the footing are going to have, for example, 40 centimeters, and this beam are going to get say 60 centimeters. So with these selections, the foundation are going to take that that height of the beam. So I prefer, to choose the one doing by calculations. It's called footing depth resulting from design. I prefer to check this one, to select that one, and then continue. The same for the strip footing options, the same thing for design. Okay. Okay. So now when it's done, we can go back, and do our verification. So we go now for the part number 5. And in this case, what I'm going to do is to modify the tension. Sometimes, if you have a large foundation, perhaps in some areas, we have a different soil, different tension. So just only that particular column that are going to modify these tensions. So I'm going to go for 2.5 and something else like 3.75 and accept it. And the program also, we can do the design. We can go for designs and complete because I changed the geometry. Okay. So all the checks have been modified and verified, and the report is something like that. It's okay. I know the report is not, well done in terms of of details, but at least give you if we have any problems regarding to the analysis. So now we have a different shape, if you want to see the 3D view, is something like that. And also, just taking advantage of this graph or this 3D view, one of the best normal question that everybody asking me is if they can modify or work a little bit with the height or the geometry of the foundation. The footing, the height of the geometry is setting by this geometry of this element, this geometry that I'm showing right now. This length is attached to the geometry design. In the design process, we must select this section, and goes by the bar. So the vertical bars, the only way to change it here is going in the column designs. So in the column designs, you can modify the bar for not for because they give you the best bar. For example, you go for one inch diameter, and over there you can change it for something similar with 2 lower diameter, and in that case, you can get a better geometry results. This is one of the solutions. What else? Well, now we go for 14, 8, and 9. We can edit. In here, what I'm going to modify is the reinforcement. The reinforcements could be by the bottom reinforcement, by top reinforcement, and also the perimeter one. If I choose the perimeter one, we go for example, by this diameter. I'm going to keep the overlap 40, and look what is going to happen. Look this side, this area, this graphic over here. So you are going, we are introducing these 4 bars over here around. It will show you here. So this in case you need it, but at least you know where to go. At the same time, you can change the materials, you can change the geometry, the reinforcements, and if you want to see, for example, I'm going to get back to the same situation. Remember that code design or code check is proof that it's verifying that the footing is well designed. We go now for the option. We're going to edit P2, for example, C2. In C2, the option that I'm going to introduce is the could be a single one, which is everybody knows about this solution. In particular, we are using exactly the same solution because we have almost the same graph, and also the advanced design. The advanced design is that on the bottom you have the initial overhang fixed, and the value is 0. That means that in this column, we are not allowed to go in this side from this side, because perhaps there is something else. Maybe we have a building or something else, so we are not allowed to do these sides. And also the convention here about this grow. I can grow the footing in the X direction and the Y direction. So the convention is going to be from the right side, for example, from the right side to the border or the edge of the column. This is the right side of the position X, and in the left side, you are going to work to grow the footing from the left side up to the edge of the column. Same thing for the Y position. Same thing for the Y position. Okay. And if I'm going to change, for example, one of the piles, I can change the selection type. Remember that we are working just for the rectangular one and the eccentrical one. But we have this one, the temperate square footing. I'm going to select this, the center one, and edit. Edit. It's going to be different shape. I don't know, people, depends on the project, which is like this. Okay, and now I'm going to edit number 7, this number 7. In number 7, we're going to show the 3D view, because every time, in this project, the bars are changing. You see, every time I choose different columns, you will see the reinforcements is different. Okay. Okay. Okay, one second. Okay. Um, we have other options, like for example, suppose inside the structure or outside the structure, but I forgot to do the analysis. 1 second. Once you edit, if you are checking, I did the calculation initially about the upper structure. But once I'm start working with the foundation, only with edit the elements, the program are going to analyze or run or perform the analysis by itself. You don't have to do the analysis all the time. Just with clicking the elements, it's going to do the analysis. You see, now we go for the complete analysis, and I'm not going to show the report, but it modify automatically the footing. You see. Oh, every time, I forgot. This thing happens so many times. I forgot to do accept. You can modify here. You can do the analysis, but it's modified already. But I closed the window, but I forgot to tell the program to accept all these calculations. These things even happened to me. So now it's okay. Well, the next part, the following part is suppose that we have problems inside the structure. Perhaps we have a stone and we are not going to remove it, or kind of pipe or something else that are going to interfere with my foundation. So for this kind, we can do something in particular. We go for the limit, foundation limits, and you can introduce by 2 points, for example. I can click in the corner, this corner, and I cut this part of the foundation. Also, I can do another one. Can do it here. You can introduce the orthogonal view command, orthogonal command. So you cut the foundation in 2 parts. Now we can go for the analysis, which is the foundation elements. Edit. Remember, with editing we can do it. Another program do exactly accept this modification. And also you can do the design all complete. Yeah, you see, this modification give me a different geometry for sure. And also the kind of reinforcement. The reinforcement will be changed a little bit. I'm doing it for the second one. You see in 3D view like this. I'm going to do the designs complete. I'm not going to see the view. You see? Okay, and accept it. Right? All right, so now I think we already finished with this part, and now I'm going to introduce different elements. For example, we did the reinforcement concrete, then we did the mass concrete footing. Select the type. We are going to continue with the square here. So the square, this is the mass. Now, did you see the difference? It's only just concrete. The only reinforcement that we know already is the column reinforcement. Um, in this, we also we can design it. Well, here in the materials, you can change the kind of material. Could be the concrete, could be the steel, even the analysis of bearing pressure, the geometry as well. Reinforcement will look we have no options for reinforcement. So if you want to introduce it, you have to click here and start continue doing the reinforcements. But it's not going to be just mass concrete. We have no options here, and the code check. Some of the check has not been verified. So we have so many problems here with this selection. Now I'm going to the design, complete on the check, and I'm going to see it. But at the report, at least the report shows you that everything is clear. You know. Now, if I'm okay with this design, just accept it. This is just mass. It's only mass concrete. Accept it. Right. Now we go for piles. So we go for new one and pile caps. The type of caps, pile caps, we have a variety of them. The one I'm going to work is the pile cap with 3, and we must select the pile. So I already had one. I'm going to show you what I did. You must introduce a reference for the new pile and give a diameter, this kind of diameter 300 millimeters. And also you can choose the symbol. There are several symbols here. And the pile carrying capacity. This program are not checking the piles. They only check that it does is the pile cap. Once I define the pile, I can define a bearing capacity. The maximum load that can reach that pile by calculation, okay? Also, doesn't check the efficiency of the pipe or the group, and neither by the point or nor by the shaft. This is something that has to be clear. We are just doing the pipe. Accept that. Okay. We can edit. Now the program are doing the calculations. I show you the 3D view. You see, these micropilots or pilots, we are not checking these piles. Okay, we are working just with the mass, with the cut. I'm going to do the designs. Well, before doing that, I'm going to do the check. Go check. And this report is very well done. It's better than the one before. And once you navigate, you go through all these report. All this kind of mark is we are not the program doesn't fulfill all the requirements, especially for the shrinkage and temperature reinforcement. And we do this kind of analysis. In this kind, the strength of the tie is not working well. You see? So we must work on it. I'm going to close it. So one of the things is I can design, complete. And now I show you the report. And now the report is clean. Everything, everything in green color means that it's okay. And also give you the worst case scenario when they are doing the calculation. Okay, so everything is okay now. Right? Close it. And don't forget, to to accept. The Extrude 3D is something that we work with these entities in Europe, and it'll give you all the combination that we are using it. Okay, and you can view how the column is transmitting all the axle and stress in these three columns. Well, kind of columns, right? And accepted. Okay, good. So before I'm going back, to the solution. Remember that in undo and redo, we can do it 20 times. If you don't want to lose information, you better set up the maximum number of actions could be 20. And I select the one before here. I'm sorry. So I'm going to do something different. Okay. Sorry, 1 second. I'm going to do it again. I'm going to delete it. All right. I'm going to do it again. Case 2. Vale. And then edit. Remember, edit. Okay, I'm going to accept it just right away. So it's in red mark. That means that we have problems. So I did this, one of the solutions, which is designed the foundation straight, but for sure I can modify the columns or the beams who are around the foundation. So one of the solution is to select the strap and tie beam. On the bottom, something here we call the balance ends. That means that at the end, this is only a tie beam. So if I click in the bottom, I introduce that kind of moment. So remember that we have a lot of problems in the beginning, but maybe this kind of solution can give me a better results. So now we go back to the foundation elements, edit, and now I'm going to see the report. I know we have problems, but at less than before, for sure. Okay. Look, we're still having problem here, even here, and so on, but less than before, for sure. Just because of that modification. So the best solution is to go here for the designs and do it completely. Okay, that's all. That's all for this part. Okay, so the reinforcement changed a lot. I show you that. It also introduced some diagonal bars. You see, I forgot to accept that modification. I lost the modifications. I have to do it again. I'm sorry, guys. Okay, and now accept it. Now it's okay. Okay, the next step is what I'm going to do now is to edit the beams. This beam that I already had. We go for foundation and strap and tie beam. Edit the beam. This one. You see, before doing the analysis, for sure the height of this pipe is greater than we have now. um, In this beam, you can also select the modify. You can modify from here the type of straps. You can change the stirrups. You can change that as well. In the anchors, and also you can select the code check right away. If something happened, it will give you right away. It will tell you right away. Now we have problems. The minimum reinforcement is due to biaxial bending. We have problem in the bottom. Also, there is something that you have to take in mind, that some of the solution, the results were very close. It's up to you, to assume these results. You don't have to follow all the way the results here. And the design. I'm going to do the design complete. Now it's okay. Remember that we are having problems with that beam. Now it's getting better. The type, for sure, it would change. And the reinforcements also change a lot. So in the 3D view, one more time, something like this. Okay. The yeah, it's like that. Then you can see it better. All right. And then something that I forgot to, well, we can go now for another example. I already had that example. I'm going to introduce a new project, which I already have done it. It's case 2. Which is a mass. This is a foundation. I'll show you the building. Okay. On the bottom, I'm going to introduce this kind of foundation, which is different than the one before. That means the foundation is the soil that we're going to work is bad soil. So we better go for this kind of slab. The way to do it is pretty simple. One of the beams that I use for the perimeter one, I'm going to edit one just to show you. It's called the non-structural or limit beam. But you can also use the foundation beam. With the foundation beam, as you know, you have to introduce the width and depth and the tensions, also the subgrade model. The subgrade models, the subgrade model, I forgot to tell you that in the analysis, in help, on this button, you can check in calculations. You can check the calculations, which I have here already. Let me show you a better view. Over here, you have on the bottom, this is a formula to transform the subgrade models of the 30 by 30 plate that is in lab. In the lab, they do that test with that plate, which is the dimension of that plate is 30 by 30. So in this mass, you have to transform these values to the foundation that we already have. So this is the way to do it. And in the manual, you will get it in the page 78, I think so, 78, 79. It's well explained, the way to do it. Okay, and also you have an extra graph and a table showing you the soil, where you can check the soil type and also the subgrade model here if you don't have it. This is roughly an idea of what you are going to use. And then, well, I'm going to do it now with this, one of those, could be the flat reinforcement beam. The same information here. Also, if you choose the foundation beam, this information has to be equal to the one in the mass foundation, in the slab foundation. If you make a mistake and you don't do the same values, you don't use the same values, the problem are going to tell you that something is going on. If it's okay, you accept it, they are going to finish with the calculation, but at least they will allow you to change or modify the values. For example, like this, sorry, beams defined, the foundation one, accept that. So I'm going to do it from here, like this, like this, like this, like this. Okay. Now, to way to introduce the foundation, we must cut the edges or delete this thing that we don't need. On the slab, define the panel. We have the previous one, the math foundations, the same data, Remember this gray model, you can do it through that manual. You can follow the manual. Accept it. Click in the center and one of the sides. You have it now. All right. So I'm gonna finish with this. I think I lost the calculation. Maybe let me check. Let me see. Yeah, I lost the calculation. I'm going to do it now. Won't be long. Well, you can do it with including the foundation, with the foundation. Well, just meanwhile, I can tell you that for this second foundation, from the case study number 2, I changed something in the original building because it has to force up to the limit the foundation, just to show you the results, how we are going to work and the way we are going to work. So you see we have a red column here, and on the bottom, on the other corner, we have a red one. That's because I did something like that. In this column, I introduce negative value. It's a load in a negative value. That means that it's like somebody is pulling up, this structure, and the other side of the corner, I'm doing the opposite one. In this part, I'm introducing different load, but vertical ones. So could be favorable or not favorable load. When it's finished, we go straight to the jump. We go for the results. And we can introduce, for example, in view, we go for flat waffle slabs, the views. Okay, the views. From here, I can show you the base reinforcement, the predefined reinforcement, could be the longitudinal one. In this case, it's better not to choose all of them because you will not be able to see it. So the best thing is to choose the longitudinal one, could be the bottom or the top, but not both of them. Okay, so I'm going to choose the top. And what else? I can choose also. Yeah, I think it's okay. All of them accepted. So we go for the results. One second. The diameter, the length. Okay. And vale. Okay. So this is our distribution. Um, um, well, later if you want to change or organize in a better way the reinforcements, there are two ways of doing it. So we can go here to overlap, and check the excessive bearing pressure in the mat foundation. Could be here, and you can click, everywhere, and they give you the maximum bearing pressure. Right now it's 1 point, it's positive 1, but once we're getting inside, it's getting graded and graded. So this is the limit. The maximum bearing pressure is go for 4.55. But because I did that load, positive load, and for the uplift mat foundations, so we got in the other side. You see the maximum upload verify is negative here. What I need is this negative value. That means the upper structure are doing its job, and give you that negative value. But if you go inside, you will get something positive up to the limit, which is going to be 2.23 millimeters. What is going to be the solution? The solution could be to increase the volume in this area, some mass, or give more load on the on top. There are different solutions, okay? But at least give you that modification. Also, in the contour map, you will see the displacements. Also, the ground bearing pressure, which is on top. Over here, you will see in different color. It's like almost gray, and the bottom we have a lot of stress. Yeah, the value is over here 4.68 kilograms by square divided by square centimeters. And I think that's all. That's all. So this is these are my presentation. Is like that, but I'm going to show you a real case scenario, which is this building. Well, I'm going to show you in 3D. This building is under construction in the city of Cartagena, in the north side of Colombia. This is the Hilton Hotel. Oh, it's taking a while because it's a huge. Okay, this is the building, and we have on top a swimming pool here, two swimming pool, and on the bottom we have another swimming pool. So you can see this is a very nice software